Good morning, evening, afternoon, wherever in the world you are today. Hope everyone's having a pleasant evening. Welcome back, anyone returning, and welcome anyone who is new. So I want to do something a bit different today. I am currently very much in the weeds of the next video, and it's really giving me a headache, and I wanted to do something a bit different and I don't know, fun maybe. I don't know if I'd say relaxing. It's templates in C++. It's never relaxing, but just have a little play around with some template metaprogramming. Maybe something you've seen before, maybe something you've not. Hopefully there's something new for everyone. Just gonna write some code and talk about it, and we'll see kind of where we get to today. I've got a rough plan in my head of things to go through, but we'll see where we get to. Cool. So, what is template metaprogramming? C++ has this concept called templates. The idea is that you can use it to write generic code. And if you've used any C++ before, you've used templates whether you know it or not. The standard library is heavily templated, which allows you to have things like a vector, a dynamic array, which is templated on a particular type. So at compile time, the compiler, if you have just a vector of ints, then the compiler, when it instantiates this template, will go and take all the code for the vector, and everywhere it uses a type, it will create a version of that with int. And then if you do another one, it will create it with float, etc., etc. The idea is you can go and get maximally performant and generic code because the compiler is generating you a version of that code per that type, which is pretty cool. A lot of languages have the concept of generics. I'm not too familiar with the implementation details of many of them, but C++ is pretty powerful in that respect. What the interesting thing is that actually the templates themselves are actually Turing complete, so you can do computation in it. And I think this kind of maybe started off as like an intellectual curio, but as time's gone on and the language has evolved, it's getting more and more, it's getting easier to do and more popular to try and offload as much execution as you can to the compiler, because in theory the more the compiler does, the less you have to do at runtime, so the more optimal your code is, or the less chances there are for errors and bugs. So as over the recent editions of the language, they've added more things that make compile time and execution, if you will, easier. Constexpr, if you've ever seen that, or consteval, these kind of things which basically tell the compiler, either you can or you must execute this at compile time. So we're getting now to the point where we can write more and more what I would call like normal C++ code, and the compiler has enough information and context to be able to execute that code at compile time and effectively just pre-populate that result for you in your binary. So I want to kind of go through a little bit of a tour of some different template metaprogramming techniques, some sort of slightly older school ones. Then we're going to look at some of the newer ones, and just have a bit of fun with it. So what's going to be kind of like a driver for a lot of this is a compile time vector. I'm just doing it of ints. So the idea here is that within the type system, I can encode numbers. So this here is what's called a non-template type parameter, and the ... means it's variadic. So I can basically create whatever I want, right? And this forms part of the type, but it's all known to the compiler. There's no execution that's going on here. But that's kind of okay and fine. I can parameterize an object with some numbers, but like how to actually do computation with those. So the slightly, I guess, older school way is with specialization of structs, and we'll start off with that, and then we'll kind of see what we get to. Do I think replacing static assert with constval representation would be a good idea? I am unsure of the implications. Otherwise, why? I think it's a good question. I've not really thought about it. I guess they kind of do potentially different things, because a static assert will stop your compiler from compiling if it fails. So how would the const eval work? I assume you're saying like if it is you cannot compute it at compile time, then that should stop, because then it's not const eval. I'm not really sure like how you would kind of get the same functionality from both of them, but it's an interesting question. Thank you very much for the super chat, Emre. I'll give it a go. Very much appreciated. Okay, so I've got my compile time vector integers, and we can start writing some functionality for that. So I'm going to create a class, a templated struct called popFront. And the idea of this is that at compile time, I'll be able to pop the top element off that vector. And what that kind of means is produce a new type, which is the same as the other type, but without that first integer. So what we can do is we can do this through partial specialization. So let's create our partial specialization of popFront. So really it's all about pattern matching. So we basically want to say, hey, when I get a vector when I can match something like this as a template parameter, i.e. a vector with at least two elements, one and then at least one element, one and then the rest, then I can instantiate this template, and then through that I can kind of effectively have some effect on it at compile time. So we need to specify our parameters. And then I can just say sort of using my new type, which would be how I kind of reify this into something I can actually use as a type later on. Vectail ... right? Yes, sorry, thank you. Yes, one element parameter pack can be empty. So that's pretty good. So I can basically say, look, when I have one or more elements, remove the element, remove that, create a new type which just doesn't have that first type. And again, we can use static assert, as someone was mentioning earlier, to verify this. The same as popFront vec1, 2, 3 type should be the same as 2, 3. And all being well, nothing will happen. So the reason I'm using Godbolt today is just because everything I'm going to be doing at compile time, and it's just nice that through the web interface this instantly compiles it and gives me the output. So if all goes well, we will produce no assembly, no actual code today. We will just make the compiler not error, and that means for us in this particular case and circumstance, we've achieved the effect that we want. So yeah, let me know if the font size is big enough. I never really know if that's big enough for me. I don't know if it's illegible for anyone else, but do let me know. I can always embiggen it. So this is kind of like the introduction, I guess, like the first steps of kind of template metaprogramming. We can partially specialize structs, which then allow us to produce new types, because again, we're not working on values, we're only working on types. So at compile time, everything has to kind of work on types. Although it's not quite the case when we get into constexpr a bit later, but sort of for this point, everything is type. So create a struct, partially specialize it, create a new type. And then we can what we can also do here is recurse, which is the real power of kind of doing this, is we can iteratively do something until we reach some sort of base case, and then like the whole thing comes together at the end to get the value. So there's several ways of getting the size, like how many elements are in here. The real old school way is to recursively count them, which I'll do first, then we'll go into like how you would actually do it now. But say I had another, there's gonna be a lot of typing sort of this today. Alright, so I want to create a size struct, and I want that to count the number of elements in the vector or in the vector type list. So we can do something similar to this and just keep popping them off until we end up at an empty vector, at which point we know we're ended, and we can just count how many times we've done that. So struct size, vec, head, tail, and basically there'll be a static const expr int value equals 1 plus the size of vec tail value. So we're declaring a struct with a static member, and that will recursively call itself, but without the head element, till eventually we end up with an empty struct. And then that's the base case. So recursion, pretty standard, you need to come sort of terminating base case. So we can just fully specialize the struct at this point and just say struct size vec and then static const expr int value equals 0, because an empty struct, an empty vector has a size of 0. Yes, the the ellipses kind of goes in different places depending on where they are in the language. I didn't design the grammar. I had no say in it. I just try and remember the rules. I will almost certainly get this one wrong at some point this evening and put it on the wrong side, and then we'll get a grumpy compiler message. So again, static assert, what we're going to do, size of vec 1, 2, 3, value equals 3. So that's fine with that. But this is a bit of a pain, and there's actually better ways of doing it now. As of C++ 14, you can have templated variables, which sounds, I don't know, didn't really see it seems a bit strange when I first heard about it, but it does have some uses. Like, I think the canonical example they give is like you can have a templated pi variable, and then if you template it on a float or a double, you get the right precision for the type that you want. But we can use that here to create our sort of a size variable, which templated on a vector, and then using that it will become the right size. So go to class v const expr int. It's going to call it size, and then again, because it's template, we can partially specialize it. So this would become template int nums. So when I call this on a vector with nums, this will equal, and then we can use size of ... nums, and this will basically say, so size of ... will tell you the number of elements in a pack. It's just a part of the language, so it's actually easier to use that. So now we can just use this size variable. Can a vec have a negative size? No, not in this case. Wouldn't make any sense, because because it's all done on the, you can't have a negative amount of template parameters, because it's all based on this, right? And it has to conform to this. So static. Oh my goodness. Assert size of vec 1, 2, 3 equals 3. There you go, fine. So that's templated variables. Again, kind of leverage them for metaprogramming. Hello. So again, like, I'm not gonna fully recreate a dynamic vector at compile time, but you can start adding some more functionality to it as you want. So for instance, let's say we wanted struct pushback, right? This would be analogous to C++ listed vector pushback, and you would want to add in the runtime std vector, you add a value to your vector, your internal storage, you grow it if you need to, whereas this I now need to produce a new type which has that additional non-template type parameter as part of the parameter pack. So we can specialize this. So template int nums int value, and then push back if we passed it a vec with nums dot 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 and a value. Then we will create a new type or an alias, which allows us to access the type of a vec of nums dot 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 value. Is that the right way? Yeah, you want the existing numbers and then the new value at the end. If anyone's done any Haskell, this kind of programming where you kind of recursively just take the head off of a pack and leave the rest, it's very similar to that. And that help. I know people who have sort of come to this kind of programming before, and when they realise it's very much like Haskell, which they have the experience in, it's made things a lot easier. I guess if you don't know what template metaprogramming is, then the title isn't particularly of the stream isn't particularly useful. But it is what we're doing today, so we're getting the compiler to do work for us. Yes, I think it's a universal truth that you cannot type when someone's watching, which actually is not great for streaming. But here we go. I'm sure everyone will bear with me as I try and figure out what I'm doing with my life. Okay, so static assert stirred same. I should put this in a macro because otherwise I'm going to be typing this a lot. But hey ho, push back vec 1, 2, 3, and then 10, and then close that and type, and then vec. So that's going to be 1, 2. We really don't need this window so big. 1, 2, 3, 10. Does that blend? Oh, I made a mistake. That's more useful. Let's actually have the compiler output. If I just not balanced my my brackets somewhere. Yes, you can do the same thing with type lists. I'm just using ints today just because it's easier. And there's some sort of interesting sort of numerical calculations we can do with this. If I missed a type somewhere. Yes, thank you. Nailed it. Well done. I'm glad someone's paying attention. This will happen a lot because angle brackets are everywhere with C++ templates, and it's very easy to add an extra one. And, you know, the compiler isn't always the most forthcoming with why it doesn't like it. It sure knows it doesn't like it, but it will give you a variety, a range of usefulness in the error messaging. So that's fine. You could do push front, push back, pop front, whatever you want to do. What you can also do is have this concept of like an out vector. So as in like somewhere you can, it's not really storing data because it's not running, but you can use it to generate new types as you go along to kind of keep track of additional state as your compiler is very diligently churning through all of your recursive template instantiations. So what do I mean? Let's try. I'm going to set this as a default, so it means when I actually use this, I don't have to specify it, but it is kind of available for the partial specializations. So say I wanted to reverse this list. What I want to do is do something very similar to what we've done before thus far, and take the head element and move it somewhere else, and keep basically consuming this vector and putting it into this out one, but in the reverse order. Again, so we can kind of recursively take elements, or in this case, template type parameters, so integers, and manipulate them, in this case, push them into a new type. So what's that going to be? That's going to be it's going to be a head. Nope, it's not going to be a class. It's definitely going to be an int head, and then it's going to be an int tail, and then it's going to be an int out. This out is separately named to this out. It's just the way I've, in my mind, I think about it, but they could be called separate things. Struct reverse vec head tail dot dot dot, and then this is kind of vec out dot dot dot. So again, it's kind of just pattern matching, basically saying when I match this, instantiate this partial specialization, which you'll do every time you give it a vector with some numbers in it. And because this is defaulted, it means you don't have to worry about handling this. It's just kind of there for you. So using type, we can do reverse vec tail, so they pop off the head, as it were, and then vec. I always get this the wrong way around. I think you want to put, even though it's reversed, you want to put the new one here, and then the rest here, because you're going to take the existing ones you've got and move the new one in front of it, which is effectively going to reverse it. Go is on my never-ending and never-shortening to-do list to learn, because I hear like really interesting things about it. I really like coroutines in C++, and I really want to give Go routines a shot. I just not had time yet. So static asserts the same as. Everyone bored of watching me write this yet? Reverse vec 1 2 3. Treat ourselves to a fourth. Type vec 4 3 2 1. See where I've gone wrong this time. Where is it not like that? No name type instruct reverse. Oh, am I going to need I need a base case on it. Again, because it's recursing, eventually it will run out of elements here, which means it can't match. Like this says there has to be at least one element, so it can't match that. So what we can do is we can just provide a specialization for the base case of our recursion. So struct reverse. So if I match an empty vector, but a vector with some integers in the out, then my type is just the result, right? Because this will be the base case. There you go, nailed it, done. No compile errors. So that's all well and good. Let's take a quick detour into that and do something a bit more interesting. I guess everyone is probably a classic. This is sort of a classic template metaprogramming example is calculating the Fibonacci numbers. So I'm going to go through that, but the reason I want to go through it is because there's a few interesting ways you can do this, and maybe something that people have not seen before, using the sort of constexpr way of doing it. Isn't a list of things reversible for anything, not just ints? Yeah, I mean you can make this a type list, right? I'm just doing this with integers because later on I want to do more sort of numerical calculations. So I'm just kind of sticking with the concept of not a C++ concept, the idea of a compile time vector of integers. But you could, I mean, if you want to be really fancy, you could template this and then have like that, if you want to be really generic. That will break all my code, but an exercise for the reader if you want to try doing something like that. I will, if I remember, I will post the Godbolt link at the end so people can have a play around with it and have a look at what's going on. So size t. Should we just stick with ints? So one of the ways to do Fibonacci is with the templated variables like we discussed earlier. So int fib equals fib of n minus 2 plus fib of m minus 1. Right, and then we can fully specialize that for the base cases. Okay, and then what? Static. Now I've got to remember what the Fibonacci numbers are. So fib of 2 would be 2 with a 0 indexed, and then f2 3 would be 3, and then I know pretty reasonably happily that I'm not gonna put them all there because I believe there's quite a lot of integers. I'll probably be here all day trying to enumerate them all. So that's like, I guess that's kind of like a canonical template metaprogramming way of doing Fibonacci. You could probably do it with this. Well, you could definitely do it with the struct method. I just did it with the templated variable. Yeah, I mean, if I was doing this properly, I would size t it, but int is slightly less typing and just trying to keep it consistent. But yeah, you're right. We could be better. I'm just not at the moment. Now, what I think is another interesting way of doing this is to just leverage constexpr. So write a constexpr function which does the computation, and then the compiler will execute that compile time and make the result available to you. So we can kind of even leverage the standard library a bit, because pretty much all the standard library is, or a good chunk of the standard library is now constexpr. So that's all the algorithms, that's vector. For instance, you can have a compile time vector. The compiler does the dynamic allocation for you and eventually produces you a vector with the right values in, map, string, most of those. So let's try that. So let's do. Go on. Tell you what. You know what? We'll do size t. Now, so because this is all constexpr time, we can create an array, a C array, sorry, a C++ array, and what I'm going to do is I'm going to initialize the first element to 1. So this will have n elements where the first one is 1 and the rest are all 0. It'll default initialized, which will be 0 initialized, which will be 0. Yes, you're right, you can use auto. I'm going to use that for one of the examples I want to later. We're going to rely on using auto for non-template type parameters. Same as is a concept, whereas you might have seen before is same v, which is a struct which uses spin to check them, whereas same as is a C++20 concept. So yeah, this is just a concept that it basically uses is same under the hood, but it just presents itself as a concept, which means you can use it in places that require a concept. I just find it less typing because you don't have to use the is same underscore v. You can just use same as. So there's an interesting algorithm in the standard library called adjacent difference, which, given a series of elements in a container, given 2 iterators, it will calculate the difference between them, like through each consecutive pair, and then you can provide like a custom binary operator and even a custom output. So what you can do is you can do std adjacent difference std begin my array. So I want to go from array to array -1, so just one before the end, because I want my output iterator, like where I want to write the results to be 1 from the start. So basically I'm going to go through every single consecutive pair, stop at the end, but I'm kind of writing one ahead, if that makes sense. And then the difference operator, like the way I want to calculate the difference, is actually to add them up. So this, because it's all adjacent difference itself, is constexpr since C++20, and I'm compiling in my big old dome's in the way, but C++23. We get access to this at compile time. So static assert fib of n, I don't know, 4, is that as far as we've got, equals std array int 4 1 1 2 3. Oh, let's do 5. There you go. Compile time Fibonacci done. So if you wanna impress your mates down the pub, or but asked to do Fibonacci in an interview, just know that the standard will basically, you can do it using just standard primitives, and you can do it all at compile time if you really want to. So you can't just make variables typed auto without typing the word auto. All variables require a type. That's just the way the language works. C++ cares very deeply about types and sizes and making sure it can allocate things. So you have to give every variable has a type. That being said, you can use auto to just deduce the type of a variable based on what is the expression being evaluated to initialize that, if that makes sense. But you can also use auto here, which we'll have a play around later. I've got some more. I don't know if it's forbidden C++ knowledge, but there's a few other little interesting C++ tricks I want to get through. Later. Now let's do something. Let's go back to our vector. I mean, it does infer it, but so I'll tell you what you're saying is like, I don't know, auto x equals 1, right? So this is an integer. X auto is inferred. Sorry. Auto has deduced this to be an integer, so this is the equivalent of doing int x equals 1. You're saying, why can't I just do this? Because the language just doesn't allow it. You cannot. This is effectively assigning to an existing variable, not instantiating a new one. So you have to have some type specifier there, even if it's auto, to tell the language that you are declaring a new variable. If constexpr inside a template is very cursed. I mean, if constexpr, just use it wherever you need to. Do you know? Like, it's just if you know that the compiler is just going to execute it, then you might as well have it not compile the other branches. If expr is really powerful, I quite like it. I don't know if any of the stuff I want to get through today specifically needs it, but I do have some streams in the future where plans for where I want to implement more of the standard library live, which could use constexpr if constexpr. So let's go back to where we were before with our compile time vector of integers. Let's do some more pattern matching computation on it. Something a bit more interesting than just reversing. Let's assume v1 plus v2 class out there. Struct merge sorted. Now here's an interesting one. Let's assume we are given two vectors, as in compile time vectors of integers, and they are both sorted. So that is the preconditions, they're both sorted. Can we merge them into one list where they are, but still maintains the sorted order? The answer is yes, we can. We're going to do it now, but that's the game. We're going to try and merge two sorted lists. I've just started studying IT and learning algorithms in C++, but I feel like it's black magic. Do you have to work hard on it, or is it just not suited for you? I think any programming language requires hard work to learn. Like C++ is exceptionally complex, but I think for someone, especially if you're new to the field of programming, all programming languages are complex, and really just like knowing your tools, as in like knowing what your language and your standard libraries provide you, is a huge part of the battle. I just happen to know there's an adjacent difference in the algorithms library, but I spent a lot of time kind of going through the algorithms library to see what is there, to see where I can kind of make use of stuff. It is a bit of a slog. Don't get bogged down with it. Like, I kind of think of it more as like there's always something new and interesting to find and play with. So yeah, I wouldn't stress too much about it. I mean, if your first programming language is C++, I think you have set yourself up for quite a challenge, but it doesn't mean it's not possible. I just think learning C++ in 2024 is quite a tall order, especially if you have no existing programming language. But it doesn't mean it's impossible, and you should definitely stick with it if you're enjoying it and getting some value out of it. If you like code, of course you can stay. Okay, now we're going to get into some real token soup now. So basically, the way you can merge two sorted lists is you take the first element from each of them and you compare whichever one is less. If you know that one is less, whichever one is less has to be the next one. And then you kind of recursively, you pop that one off that list and recursively go through until both lists are empty, or until at least one list is empty, and then you know the rest are going on it. The assumption being that they're both, the predicate that they're being both sorted makes this quite a bit easier. But that's enough talking, more coding. So all the template arguments this time, all of them. Okay. So now my type is basically going to be based on whether the first element is less than the first head is less than the second head. If it is, then I will stick this into out, and then I'll recurse on tail 1 and leave this the same. If it's not, I will do the inverse. I'm going to say a dot. I think starting with C and transition to C++ is a valid path, because I think C is I don't want to say it's easy, but comparatively it is a very simple language. The standard library that comes with it is very simple. There's not it's not nearly as many language features as C++. I think C is a great introduction to low-level systems programming. It'll teach you about pointers, and it'll teach you about undefined behavior and the need to do manual resource allocation and interacting with the OS and all that kind of good stuff that C++ then just provides another layer on top to make that kind of easier. But as an intro, I think I would recommend someone I would definitely recommend people learn C if they want to. Do you know what I mean? I still think it has use. Would I do a large scale project in C? Probably not. But if someone was looking for a more gentle introduction to, say, pointers and memory management, C is great because there's not a lot of chuff around it. If you're learning by yourself and you just pick up C++, there's just so much. I could see how you could very easily get bogged down with it. So yeah, that's kind of my view. Definitely start with probably C++. If you can, always use the latest version. So C++ 20 or 23 if you can. Not all the features are in all the compilers yet. And there's sort of a lot of stuff I'm doing, like say Spin and stuff, like some of the old school techniques. They're a massive pain. I still think they're just kind of fun. I think it's kind of fun to have a play around with, and if you're not that familiar with it, it's kind of an interesting insight. The thing I want to cover at the end is if we get time to it, there is one really interesting example of really leveraging modern C++ compile time techniques to do something quite cool. which hopefully we'll get time to do. So there's a templated type in the standard library called conditional T. This takes 3 template parameters, a Boolean, and then 2 types. And then depending on if the Boolean is true, then it resolves to the first type. If it's false, it resolves to the second type. So you can kind of think of this as a compile time if statement, which is exactly what we want, because I want to say head1 is less than head2. Then merge sorted vec tail dot 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 vec head2 tail2 dot dot out out head1. I think that's the way I want to do it. I want to take all the existing elements and put the new one at the back, because it must be smaller than any ones I've already added. Yes. Type. And then again, if this is the other way around, then I want to preserve the head 1, drop that, and then make that a 2. And I will see where my errors are. I suspect I'm missing a type name, because I usually am. Compilation failed. Oh, didn't even get that far. Oh, I'm missing a struct name. I'll do it. Now we get to unlock all the fun errors. Additional T, right. Type name mismatch, I suspect, because there's an ambiguity in the language, which is always fun. I'm missing the type name, and then what else am I missing? Right, okay, so now I need the base cases as well. So the base cases are, there's going to be 2 base cases. Either the first vector is emptied or the second vector is emptied, in which case you just return the entire out vector with the remaining of the other one appended to the end of it, or appended. So yeah, let's do that. So 112, is it really out? Oh, thank you. That is a good spot. Because I was surprised that... Okay, because I was surprised for a second there, because I was like, how does it know I've not got missing a base case when I've not tried to instantiate the template yet? Like, it has no way of knowing there's a missing base case until you actually try and instantiate it. But that is a good spot. So thank you. Someone is paying attention, and it is not me. Template. So it's gonna be. So I'm basically gonna have nums out struct merge sorted vec, and then vec nums, and then vec out. Cool. And then in this case, using type equals vec of out dot, and then the remaining the remaining nums. And then we just got to do it for the other way around, which is easy enough to do, because that will be nums dot, and then that will be out. Nope, no, it'll be empty. And then we've got the same. So in theory now, if all this works, same as merge sorted vec 1 3 5 vec 2 4 6 and then type, and then vec 1 2 3 4 5 6. Oh, nailed it! Absolutely crushed it. So yeah, but let's go a little bit further. Well, it's not quite done with this yet. This is part of the story I'm trying to get to. Let's do splitting a list, and I guess now that I've said sort of merging a sorted list and splitting, maybe some people can get an idea of where I'm going with this. But let's try and compile time split a list. Yes, vec angle bracket is indeed an empty vector. So template class v class out equals vec struct split left. So there's a couple of ways you can do this. I'm going to do it as two separate operations. So again, template int head int tail int out struct split left vec head tail and nearly made the same mistake again. Out so what was the question? Isn't nums already implying that you're handling a list of numbers that may be an empty list? I mean, I'm pretty sure this won't work. I could be wrong. Because it's still missing a recursive base case. It still needs to know when to stop, otherwise it's going to keep calling this, so we have to match on an empty vector. Assuming that's what you were talking about. So yes, like variadic template means there could be arguments, there could not be, but I need the whole point of this is pattern matching, right? So I want to match the specific case where I have exhausted the first vector, which then allows me an opportunity to terminate the recursion. And the same here, I'm looking specifically to match, because this is partial specialization. I'm saying, here's the primary template. Here is what to do when you instantiate it with 3 vectors. But also further to that, if one of those is empty, as in it matches this pattern, this provides a better match for the compiler. So it will pick this one, which again allows me to terminate the recursion. So I'm not usually a special empty list type alias. Possibly, like, I mean, if you've got a massive template metaprogramming library, I'm sure there's lots of convenience to help us. I'm just for funsies doing some of it from scratch. So what I'm going to do is basically I'm going to take the similar to how we did reverse. I'm going to keep taking the head element and move it over to out, but I will stop when the size of out is larger than the size of head, because that means, if my maths is correct, that means we've gone past halfway, because as you kind of reduce them at some point, one will overtake the other, at which point you're kind of there. So do conditional t. We can leverage our size variable from earlier. So if size of vec out is less than size of vec head tail, then we're going to want, I'm going to need a type name here, I suspect, split left vec tail dot vec out dot head, I think. And then otherwise we have reached the halfway point, so we've split it, so all we then need to do is just return everything we've kind of captured into the out type. I got wrong. And then for this we'll need a base case But I believe for the base case, because we are always guaranteed to hit this, we just need a base case for the full instantiation, because it will try and instantiate both sides of it. So it might, although it will never end up with an empty. Is that right? Oh, you know what? That's. Oh no, eventually it will end up with an empty list. Yes, you're right. In which case we can just also return the out if that happens. Is that true? I think the template instantiation will go down. Will try and instantiate the full depth of it. So even though we should never end up with an empty vector because at some point we would have reached halfway, I believe we still need to provide one. You know, rather than prattling on about it, let's check. Same as so let's do split left vec 1 2 3 4 type vec 1 2. Yeah, I guess if you also split left on a 1, then yeah, you're right. So where's the error? Split left. No type name, type instruct. Yeah, okay, fine. So it has reached it has tried to instantiate one with the empty list, which is fine. We can handle that. I think we'll just do struct split left vec out, and then do using type equals vec. I think that's right. That is right. Okay, and for the sake of completeness, let's also try it with an odd number because I think this will give us the other one. Yeah, okay, fine here. So yeah, 1 2 3 doesn't equal 1 2, so that's correct. So we just need to add the third one there. Whew. And then split right is exactly the same. I'm sure there are clever, I'm sure there are smarter ways of doing this, but the easiest thing to do, I think, is just to basically take the same logic, but at the point, rather than returning out, once you've moved all the ones you know you want over to the other side, then you can just return your constructed, you can just return your remaining values. So this should be 3 4, and then this should be 3 4, if all is right with the world. How did I end up with an extra value there? Oh, because 5, that's fine. 1 2 3. 5, and it's because that should be a 5. Right, there you go. Nailed it. Split right can't be the... Could split right... Yeah, you might be able to reverse it and split left it and then reverse it. That's an interesting point. The only one is, does it handle the case where you've got an odd number? Because you don't want them both to end up with that extra element. I suppose we could just try it, right? Still the same as... so your suggestion was reverse of split left of reverse of vec 1 2 3 4. I think that's all the types I want. And then we'd hope for that to be 3 4. Oh, look at that. Nice. And then does that work for the case where we have 4, 5? Yeah, it doesn't handle the odd case because it's including that extra one. See, it's trying to match against 3, 4, 5. Yes, conditional T size of elements is odd. Pop one. Nice. I like it. So I'm sure some of you have guessed because this is pretty sort of CS 101, but from here we now have all the components we need to do a compile time sort. So template int nums struct sort vec nums. Right, this is where I get it all wrong. Let's give it a go. So using type equals, we want to create divide and conquer, right? So we want to merge the two sorted lists, but each list would be a sorted excuse me, sorted type name split left nums dot dot dot. Excuse me. I think that's not. I think that's largely what. Right. So that's how merge sort works. Right. You split it into two sides. You recursively call sort on that, and then you merge them back together. So where have I gone wrong? Let's see if we can start balancing out some of these brackets because it's going to be a nightmare. Have I got... Oh, hang on. So, missing the vector. Right, and then the base case is when you have but one element left, because then that is sorted by definition. So, template int num struct sort vec num using type equals vec num. Let's give it a go. What could go wrong? Static assert stood. Oh my god, it's not Windows. It's not. No need to be all in caps. Sorted. Anyone want to shout out their favorite integers? I'm gonna go with 1. Nope. Let's not put the lowest one first. Let's try. Yep, I knew someone was going to type that, and I'm instantly going to ignore it. 10, 4, 8, 5, 1, 4, 4, 4, 8, 5, 1, 1, 4, 3. Let's do a couple more out of order. Let's do 10, 3, and 99. Also, right. And 0. Nice. Right, okay. Type vec. Now I've got to do this in my head. 0, 3, 10. I think we've got enough integers now, guys. Oh, minus 55. What a great a lie. Let's try that. minus 55, 0, 3, 10, 99, 4, 8, 5, 1, 1, 4. Sort. I do have two 10s. Oh, ah. It worked. compile time sorting. Yeah, so not really much more to say about that. Like, just build up a bunch of compile time primitives and yeah, just let the compiler do all the hard work. There is one more thing I want to go through today, because the end solution, or one of the end solutions, I think is absolutely fascinating, and it blew my mind when someone first showed this to me. Your mileage may vary; you might not find it as interesting as I do, but yeah, we'll give it a go. So the problem is that of uniqueness. So let's take it's starting to sound like leak code now, which I'm not a massive fan of, but here we are. Assume a sorted list of a sorted vector of integers, compile time, yada yada yada, and we want to remove all duplicates. So well, let me write the test case first, and then it'll hopefully make sense what I'm talking about. So static assert the same as unique vec 1 1 1 2 2 3 4 4 4 4 4. So this should become 1 2 3 4. So the idea is that you want to remove all duplicates to end up with a unique list. This obviously won't compile because I've not done any specialization yet. But that's the end goal. That's what we want to get to. Oh, I don't know what the disjunction trick is. Maybe there's another trick to this that I'm unaware of. That's exciting. I'm going to do it the kind of slightly older school way that I've been doing thus far, with sort of the pattern matching specialization. So int head, int tail, int out, and then struct unique. So this is interesting. So what you can do is you can actually duplicate this and basically say, oh, in the case where you match two of the same element, then I can handle that specifically, which means those are duplicated, right? So using type equals unique. Yes, this only works for sorted lists. That's part of the predicate of this, is that has to be sorted. Obviously, we have sort, so we could sort them first and then remove it. But for the sake of simplicity, let's just remove unique elements from. Sorry, let's create only unique elements from a sorted list. So what I can do here is I can basically say try again with just one of those elements, as in effectively remove the duplicate. But leave the out unchanged because that's a duplicate and we don't want to add anything to it at this point. What am I missing? Using type equals u. Oh, it's because I haven't finished specializing it. It's because I've already got the base case. So then what we can say is, well, in the case where we only match head and tail, this one here provides a better match because it's more specific. Like you have matched more template elements, so this will get preferred in the case where it sees like 1 and 1, and then when it sees 1 and 2, it can't match this, so it will fall back to this. So in this case, we know that head is a unique element because it can't match this. So we can then drop the head off, and then we can add head on the end there. And then I imagine I'm going to need some sort of base case for this. Not head at the front, no, because I'm going through the elements, so the next one that I match will be larger than anything I've previously matched, so therefore it goes at the end. It's a little bit confusing, and I often get it the wrong way around, but you are adding it to the back of the list of the ones you've already basically filtered out. So in this case, should be able to return out. No, there you go, worked. It's always one of the things where, especially in Godbot, when it's constantly compiling and checking in the background, it's always takes you by surprise when it works. I mean, it will still terminate. It'll just the answer will be wrong. It'll be in the wrong order. It'll be like, see that it's trying to match 4, 3, 2, 1 against 1, 2, 3, 4 because every time you've got a new unmatched a new element that is not a duplicate, it's sticking it at the front. So that's kind of a way of doing it, but the way the other way I want to kind of go through, which is leveraging more of sort of C++20 constexpr stuff, is a little bit more interesting. Like I said, I found this absolutely fascinating when someone first showed this to me. So kind of got to start off with the same thing. Still got to have a primary, and then we still need to specialize it. But this time, just going to match the whole vector. So we're going to need we're going to need a type, right? Get ahead of myself. So obviously, if I just had int, it's not going to like this. It's somewhere in the compiler error. It's going to look, I've returned an int, but you've expected it to be a vec 1, 2, 3, 4. Yeah, if you want to send the Godbot link for that, I'll have a look afterwards. It'll be quite interesting. I'm going to see if I can get my way through this one first. So obviously that's not going to work for us. So what I want to do is I want to leverage more of the constexpr kind of functionality. So if I do static constexpr auto do unique as a function, and then I set this to be the decal type of do unique. Then whatever this function returns, the type of it will become this type. So you should see here that it's now void, right? If I return an int, then it'll be like, here's an int. So the question is, can we construct the type within this constexpr function so that we can then deduce it and return that? The first thing we kind of want to do is we really want to go from the type system to the value system. So the idea is that these template parameters here all exist as part of effectively the type system, but I want to be able to actually manipulate those within regular code. And this is one of the reasons I picked integers, because this works for non-template type parameters. So let's create ourselves a lambda. Okay. And it's constexpr lambda. So that means the compiler will execute this at compile time. So the result of this will be known at compile time if inside it is the compiler can, if the compiler can do it at compile time, it will do it at compile time. Decl type just means return the type of the expression, so it won't actually call do unique. It will basically say what is the return type of that, and resolves that. Decl type is one of those weirder sides of it. It's got this weird rule when you give it an actual expression in brackets as well. You can use it to deduce the value category of an expression, but I wouldn't. For this, it suffices to know that this just figures out the type figures out the return type of this function. Got that in the end. So let's create a struct array. Now inside that array, I want to have an array of numbers, and the size of that will be the number of elements I passed in. So if I pass in a vector of 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever this is, say 10 elements, this will be a size of 10 integers. And also, I'm going to need to track a size as well, which we'll need later. Now, it's perfectly acceptable to declare and define an array, a struct inline, like within a scope. So let's just create one of these arrays. Now what I can do is I can say nums dot dot dot, and then dot size equals size of dot 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 nums. What this does is it uses the parameter pack expansion syntax to expand the variadic list of integers as types, but into the array constructor. So what we're ending up doing here is we can convert the template parameters as the non-template type parameters, the integers in the template pack, and we can convert those into an array, specifically a constexpr array. So the compiler still has kind of full understanding of this, and then we can return name. Right. So at the moment, this is just a lambda, right? This is just declared a lambda. There's this concept of instantly invocable lambda. So if I just put parens on the end of it, it will create and instantly call this this lambda. So R is now an array, and then so for instance, if we return r.size, remember, even though the definition is in here, we can still reference it by members. It will now say return size t, deduce this, and it's like here, long unsigned int, which is just what a size t is here. So we've kind of gone, or indeed we could do data like naught, for instance, and this be like an int. So we've gone from the type system to the value system. We now need to go backwards. Like how do we take an array, a constexpr array of numbers, and turn those into template parameters? So for this, I'm going to use another method, static constexpr. So it's going to be a template because everything is auto a std size t index dot dot dot. All right, and then this is going to be called constexpr auto to vec, and this is going to take a std index sequence of index dot dot dot. Right. So if no one's ever seen index sequence before, this is just a part of the standard library that is basically this but standardized. It's used to store a series of integers as template parameters. The way you construct this is such that they go from 0, 1, 2, 3, 4 up to some fixed numbers, i.e. they represent indices into an object. It's finally happened. I finally got it the wrong way around. I knew it was going to happen. So, as of C++ 20, you can have auto as a template type parameter, auto as a non-template type parameter, i.e. wherever you would have int or any of the other like data types that you could pass in as a template parameter. You can have auto to deduce them, as well as C++20. You can also pass in structs. Not all structs, just just ones that meet a certain criteria, i.e., they're all trivially constructible and contain basically pod types. So what this means is, because this is auto, I can accept this array, even though I don't have the definition of it at hand, and it will still be able to access those data, specifically because this R here is constructed at compile time. So the compiler knows what this struct looks like, and it knows what data is in it. So therefore, I can pass it as non-type template parameters. I always say non-template type parameters. I know it's the wrong way around. Someone just pointed it out. I do apologize. I do try to be specific with my wording in these kind of things, because when it's quite low level like this, the wording is important. So I do apologize. Non-type template parameter. So this means I can return. Well, before we get to there, let's figure out how to make this index sequence. We could just reuse all the code that we've got, but I'm just going to use the standard library one, because it's more likely what you'd be seeing in real life anyway, and it's just a little less typing for me. So constexpr auto indices that was embarrassing. Make not make unique. Make index sequence, and then r.size. So again, because this is constexpr and the compiler knows what's in it, it knows the size that's been set here, so I can pass it as a template parameter. So this means now I can call toVec on a thing, which we'll get to in a minute, and I can pass it indices. And I could use indexes. I prefer the term indices. Maybe I'm wrong. It's impossible to say. So now what I can do is I can pass in my array here. Again, this should meet the requirements in C++20 for being able to pass this object with fully constructed within the compiler, knows all the details, and match it here. So what you can now do is you can return a vec of I can call .data on it, I can access this, and then I can use my index list and unpack it to effectively convert all the elements in this array into type parameters. Which, you know, I thought this was very strange when I first saw it, and I took a couple of reads through it, and I sort of started to understand how it was all coming together. But yeah, we should be able to see now that we have successfully passed back our original array. It's still the wrong answer, but we've gone from the type system to the value system and then back again. So const was the question. What does constexpr do? It basically says that if the compiler can execute this at compile time, it should, and it also then provides some restrictions within what you can do that in order to make it so the compiler can do it. It's not guaranteed. The compiler is free to not do it, but it does provide some restrictions so that the compiler should be able to do it. So anyway, how do we still have not done the unique bit, but we're getting close. In fact, so the whole reason I wanted to do this is to kind of go back to what we did with the Fibonacci, right, with the adjacent difference. The fact that the standard library has a whole bunch of algorithms that are all constexpr. So it has a stud unique, right? And I can call that with effectively pointers. and then that will return me what is considered a past the end iterator, or past the end whatever type I pass in. So then I can just do my a.size equals end minus a.data, and all being well, if I've not made any mistakes, which I clearly have, nope, it's done. There you go. So feels a bit anticlimactic when all the errors disappear and it just says return 0. But this is a way of kind of leveraging compile time. The constexpr standard, the constexpr algorithms in the standard library is converting from the type system to the value system, working on them there, and then going back to the type system, all through the power of constexpr and the idea that the compiler is just executing all this for you. This emits no code. None of this is executed, but the compiler has gone and used like the standard library to perform some action on the data. Instead of a lambda, can you just do static const per std array in nums are nums? No, because I need to be able to do some execution, and I need to guarantee that this all happens at const x for a time. So again, this is kind of like what we were saying earlier. This fulfills all the restrictions of constexpr, and then the compiler can execute this, and then because it's immediately invoked, can just stick this straight in the R variable. I believe if you just created it in line as constexpr, it's then constexpr, and I don't think you could then go and call unique on it. I mean, I'm not an expert in template metaprogramming by any stretch. There are almost certainly ways of code golfing this to get this even smaller. This is just the way that kind of I approach it and I think about it. And when former colleague of mine who showed me this, this is kind of how I unpicked it all and went through it. What I'll probably do, I will hang on. This is kind of all I wanted to do today, but I'm happy to chat for a bit. I don't know if I can share links. But those are the Godbolt links. I'm sure SHA-1 in constexpr is probably not that bad because it's just. I mean, don't get me wrong. I can't remember what the constexpr algorithm is, but I can't remember what the SHA-1 algorithm is. But I imagine it's largely just bit shifts and zoring. So I'm sure it's definitely possible. That's kind of all I had in my mind and planned today. Like I said, I want to do something a little bit different, just because I'm a bit bogged down in the current video and needed to do something a little bit different. But I hope that's interesting. If anyone's got any questions on this, I'm happy to kind of go over it. It's kind of like token soup. Like there's lots of angle brackets and semicolon and double colons and all that kind of stuff. But hopefully people found it interesting. It's something a bit different. I want to, for next live stream, implement. What do I want to implement? Maybe something else from the standard library. I'm thinking either std any or std optional, or maybe std shared pointer. One of those. I will end up probably doing all three of them at some point, so it just depends which one I fancy doing at the time. I wanted to go back to doing code reviews as well. I've just not had the time to kind of dedicate to kind of think down what I'm going to do with that. Next, hang on, I have, for anyone who is watching on YouTube, I have the power to gift memberships, so there you go. Congratulations, five random people have. You can get a little pop up and the annoying sound as well. That's a month's worth of YouTube membership, which means you get early access to videos and a few behind the scenes posts. So do check those out. I'm hoping that the next video will be out within a month, so you'll get to see it early. It is proving quite challenging. So yeah, hopefully. Loads of std conditional, which does not instantiate the type not selected, any such thing possible. Do you mean by std conditional? Do you mean this? Because this shouldn't. I'm trying to not instantiate the type not selected. I see what you mean, because it's going to have to. It's going to have to instantiate both sides to check they're valid, even though you end up using one. I don't know if that's actually possible within the language. I'm tempted to say it might be if you do some if constexpr if shenanigans, as in like don't. Could you have an auto type return constexpr if on the condition, and then only return. You still have to instantiate the value though, because it's runtime. But yeah, interesting. In Socket in C++, I run into a problem. The server accepts first request but hangs off that. That is almost impossible to diagnose without looking at the code. I would like to get to Twitch, well, at least associate, affiliates, wherever it is. They basically make you stream like twice a week in order to meet the requirements. So if I can try and stream some more, I think we'll get there. If you want, oh, hang on, let me give me a second. There's a where's the link? There's a link for code review submissions. If you want to post your project, and maybe I'll go through it on a stream. Yeah, I mean, I'd like to stream twice a week. I have a family and a job and other well, actually, that and YouTube. Those three things, take up pretty much all my time. But yeah, I would like to try and stream more. I keep saying this, and I've not done it yet. I would like to maybe stream some games as well, just as to hang out with you guys and talk software and play some games, because I'm terrible at games. So I think that would be quite fun. Just a way of kind of adding a few extra streams. But I still want at least the Sunday stream to be quite technically focused. Yeah, so you're right. 50 followers, stream for 8 hours, stream on 7 different days to an average of 3 viewers. So I've done all those apart from the 7 different days, and I'm normally just shy of the 8 hours. So I kind of in my mind consider that to be done. Here's just check if it's the right one. Here's a Google form. If you want to submit a project to that, then it goes into my list, and I might do a code review on a live stream if that's something you're interested in. If you're only doing Sunday streams, you'd need to throw in 7 days in a, isn't it? 7 days in a 30-day period. Isn't that 2 a week? Yeah, I think they basically try and get you to do effectively 2 a week, but you can miss 1 day off. So it's like, I think it's like 7. Yeah, you're right. Seven streams in 8 weeks or something. So I don't know. Maybe I'd like to do like Wednesdays and Sundays, but we'll see. I can only do what I can do. Access denied. Oh, hang on. You're right, because I've sent you the wrong link, because I don't actually understand how computers work. Send link, copy, shorten URL, copy. Apologies, I don't really like computers and I don't understand how they work, but try that. Ignore the first link and don't ask for permission, because I think then you'll see all the answers, all the responses. I don't know if I can delete those messages. Remove. Watch me fumble around, not understand how this works. Anyway, it's fine. Yeah, I think that's all I've got. Slightly, no, it's about the normal amount of time. So yeah, next week probably do some more programming, some more C++. What I would like to do post each video is do like at least 1 or 2 live streams afterwards, kind of maybe going over the technical detail like we did with the Diablo 2 one. How come there's no community Discord, community apart from YouTube and Twitch streams? This comes up quite a lot. And someone from the chat, I think I've even seen them here today. I think it's AC, has set up a Discord, but it's private. It's not public, because I just don't have the time to kind of curate a Discord to like the level that I would want to. I don't want to just create one and then not be around to kind of actually interact with everyone. So yeah, at the moment I'm just focusing on the YouTube community and then streaming. That's kind of where my efforts are going. In the future, I would like to, I would definitely like to have like a Discord. It's just yeah, just it's a time commitment I could do without at the moment, especially considering the videos seem to be getting more and more complex, which means they're taking more and more amount of time. So yeah, maybe one day, but not at the moment. yeah, I think people are saying it's not a free thing, right? I think if you want a good like anything in life, if you get out what you put in, and I just don't have lots of time to put in at the moment. Cool. Okay, well, I think that's all from me. I'm going to kind of wrap it up there. There's a bottle of Guinness with my name on it in the fridge. So I'm going to relax and think about template metaprogramming for at least the rest of the evening. I hope those God Bowl links work for you and you're interesting. Yeah, and hope everyone enjoys the rest of the weekend. And I'll catch up with you next week.